Hello and welcome to Mrunal's math tutorial, and in today's tutorial we are going to look at some questions on permutation and combinations. I know that most of you find permutation and combination quite difficult, so I'm trying to revise a few things over here and hopefully it will help you for your upcoming exam. Alright, okay, so let's begin. Before we start with the first question, if you haven't subscribed to my channel, make sure you subscribe my channel because it just motivates me to make more such videos for you. Alright, the first question, a group of 8 friends travels to airport into taxis P and Q. Each taxi can take 4 passengers. The 8 friends divide themselves into 2 groups of 4, one group for taxi P and one group for taxi Q. John and Sarah are traveling in the same taxi. Find the number of different ways in which this can be done. So we know that there are total 8 friends. So the total over here is 8. John and Sarah are traveling in the same taxi. That means we are left with 6 people to arrange. Yeah? 6 people to arrange into taxis. Now let's say John and Sarah, they sit in taxi number A. Okay, that's the first possibility. So John and Sarah are in taxi number A. So 6 people can be arranged in how many ways? In taxi A, now 2 people are John and Sarah. And then there are 2 seats left because in all there are only 4 seats, right, in one taxi. So now 2 seats are taken by John and Sarah if they're sitting in taxi A. So we're having 2 seats left. So 6 choose 2 for taxi A. Now 4 people remaining, and in taxi B we are left with 4 seats. So 4 choose 4, right? So this is one possibility. The other possibility is that they sit in John and Sarah, they sit in taxi B. Alright, so if they're sitting in taxi B, let's say, so it's going to be again 2 seats left in taxi B. So 6 choose 2 for the 2 remaining seats because there are total 4 seats again in taxi B, right? Each taxi can take only 4 people. John and Sarah now sit in taxi B. So 2 seats remaining. So out of the 6 people, you can choose 2 people to sit there, and in taxi A then you will put the remaining 4 people, so 4 choose 4. Or you may also want to write, if you don't want to write such a long expression, you may also want to write 6 choose 2 times 4 choose 4 times 2. It means the same. If you work this out using a calculator, this turns out to be 30. So there are 30 different ways to arrange 8 people into 2 taxis. All right. Now part B. Look at the part B. Each taxi can take 1 passenger in the front and 3 passengers at the back, as shown in the diagram. Mark sits in the front of taxi P. So Mark is sitting here, and John and Sarah are sitting at the back, right, of taxi B, and they sit next to each other. Find the number of different seating arrangements that are now possible for the 8 friends. So what has been given to us? It's been given to us that Mark is sitting in the front and John and Sarah are sitting next to each other at the back. All right. So we need to find what are the different possible arrangements for the 8 friends. Now keep in mind, in taxi P, only 1 seat is left. And how many people are there now? Out of 8 friends, there are total 8 friends, right? And 3 friends are here, John, Sarah and Mark. So how many friends left then? 5 people to arrange. Yeah, 5 people to arrange. So how can you arrange these 5 people? That's what we need to find. So in taxi P, let's start with taxi P. What is happening in taxi P, right? So we have 3 seats occupied, 1, 2, and 3 already by John, Sarah, and Mark. So we have only 1 seat left, and there are 5 people. So 5 people and 1 seat. So that can be done by 5 choose 1. Again, John and Sarah are sitting next to each other, but they could sit here or they could sit here. Depends. So there are 2 factorial ways for John and Sarah to sit, right? Times John and Sarah could switch amongst themselves. That means Sarah can sit here, John sits here, or Sarah sits here and John sits the other side, right? So that can be done in, again, 2 factorial ways. Now, how many seats left? There are 1, 2, 3, 4 seats left. So that can be filled up by 4 factorial ways, right? So we have 5C1 for this 1 seat. Then we have 2 factorial because John and Sarah can switch amongst themselves. We have again 2 factorial because they could sit here or they could sit here. Yeah, so there are 2 possible ways that you can arrange them on 3 seats, right? And times 4 factorial. So in all, we're having total, if you work this out, 5C1 times 2 times 2 times 4 factorial. That gives you 480. So there are 480 ways to arrange these 8 friends under this given situation. All right, let's move on to the next question. The 40 members of a club include Ranuf and Saeed. All 40 members will travel to a concert. 35 members will travel in a coach and 5 members will travel in a car. Ranuf will be in the coach and Saeed will be in car. So it's given to you that Ranuf will be in coach and Saeed will be in car. In how many ways can the members who will travel in the coach be chosen? So we need to just find out how we will choose the members who are traveling in coach. All right, so in coach we have total 35 members, right? And we know that Ranuf will be in coach. So basically in coach we are left with Ranuf is in coach. Coach is nothing but like a bus, okay? So Ranuf is in coach. So total people left to arrange. Again, you don't need to write all this. I'm just writing to explain. 34. Total people to arrange is 34, right? That should sit in the coach, right? In all, we have 40 members, right? And if you take away Ranuf and Saeed, because Ranuf is already included and Saeed is going in cars. So if we remove those 2 people, we have 38 people left. And from 38, we need to choose 34 so that they go into the coach. So that works out to be 73,850. All right, that's pretty easy. You don't have to calculate how many people will go in the bus. The question is only about people traveling in the coach. Yeah. Let's look at question number 3. Richard has 3 blue candles, 2 red candles and 6 green candles. The candles are identical apart from the colors. He arranges the 11 candles in a line. Find the number of different arrangements of 11 candles if there is a red candle at each end. So we have red candle at each end. So in total we have 11 candles. So if the red candles are going in here, we are left with 9 spaces. 1, 2, 3, 4, 5, 6, 7. Let me just move it a little bit. 8 and 9. So there are 9 spaces left in between. Yeah. So these 9 spaces can be filled up in 9 factorial ways. Now again, there are 3 blue candles, there are 6 green candles, and they are identical apart from the color. So these candles are identical, so it's repetition. So divide by 3 factorial times 6 factorial, so that will give you 84. So 11 candles can be arranged in 84 ways if there is a red candle on either end. Part B, find the number of different arrangements of the 11 candles if all the blue candles are together and the red candles are not together. So it is told to you that the blue candles are together. So let's put them together. The 3 blue candles are together. So now how many left for us to arrange? We are left with 11 minus 3, 8 spaces to arrange. 3, 4, 5, 6, 7, 8. 8 candles to arrange, right? So we have, this is 8 and this is 1. So total again 9 factorial divided by 2 factorial times 6 factorial. So 2 is for the red identical candles and 6 is for the green identical candles. So this works out to be 252. All right, if the blues are together. Yeah. Now let's say the reds are also together. Okay, if the reds are together, so blues are together and the reds are also together. So we are left with only 6 green candle. So that is going to be, so we have, this is 6, 7, 8. So there are 8 candles to arrange. So 8 factorial divided by 6 factorial because the green are repeating. The ones which are together, we do not count it as repetition because it's counted as 1. Yeah. So total 6, 7, 8 factorial divided by 6 factorial for the green repeating. So this is when we have the reds are together. Yeah. Although I have written the reds here together, it doesn't necessarily mean that the reds are together. Over here is total possible arrangement. Okay, this is total possible arrangements, and the one below is when we have the reds together. So now all minus together is going to give you, so let's work this out. This is 56. So all minus together is going to give you the number of arrangements, that is 196, when the blue candles are together and the red candles are not together. An important point to note over here, that this method, all minus the ones which are together, will work only if you have 2 items that are repeating. Okay, only for 2 items. If it is 3 items, then you have to use method of gaps. This method will not work for 3 items. Yeah, so if I had 3 red candles, this method will not work. You have to do method of gaps. If you don't know what is method of gaps, please look up the playlist and revise a little bit about method of gaps. I have another video on permutation and combination. And also the latest video I posted about the past paper, I have explained clearly method of gaps in it. All right. Let's move to the next question. If you haven't subscribed to my channel yet, please do so. Thank you. Question number 4. Find the total number of different arrangements of 11 letters for the word caterpillar. So in the word caterpillar, we have 2 A's, then we have 2 L's, and we have 2 R's. Okay, so the total arrangements would be 11 factorial divided by the number of items that are repeating. 2 factorial times 2 factorial times 2 factorial, each for A, L and R. So this works out to be 498,960. That means it is 4,989,600. Alright. So find the total number of different arrangements for 11 letters in the word caterpillar, in which there is an R at the beginning, R at the end, and the two A's are not together. So again, you could use the method, the two A's being together, and then you minus from the total arrangements. So the total arrangements over here are going to be then, let's say R is at the front and one R is at the back. So we are left with 9 letters over here. Yeah. Remember, out of these 9 letters, there are 2 A's, there are 2 L's also, and the rest of the letters, right? So the total is going to be then 9 factorial divided by 2 factorial times 2 factorial, which is 90,720. So what are these 2 factorial and 2 factorial? This is for the 2 A's and 2 L's that are repeating over there. So these are the total possible arrangement. Total possible arrangements. And now let us look at if the A's were together. So we have the R's at the end. No need to count them. So if the A's are together, let's count them as 1. We are left with 7 letters. Yeah, so these are 7 letters, out of which, remember, the L's are 2 L's. We have 2 L's, right? So when the A's are together, we can again use the same method that we used in the previous question, is that all minus the together. Yeah. So what are the total arrangements for this? 8 factorial divided by 2 factorial, which is 20,160. So where am I getting this 8 factorial from? 7 letters and this one, which is counted as together. Total 8 items to be arranged. So 8 factorial divided by 2 factorial, because there are 2 L's. We don't count these as repetitions because the L's are fixed. They don't move. And the A's are together, so it's counted as 1. So the only things we need to arrange is rest of the letters, the 2 L's, and we count this as 1. So 8 factorial divided by 2 factorial. All right. Part C, find the total number of different selections. Now this is selections of the 6 letters from 11 letters of the word caterpillar that contain both R's and at least one A and at least one L. So we have to form different selections of 6 letters, 1, 2, 3, 4, 5, 6. What is to be included over here is they contain both the R's. So it's going to be both the R's. Let me write that down. At least one A. So it could be one A or it could be more. And at least one L. So again, one L or more. So the rest remaining spaces could be filled up by any other letter. So we have in total, we have how many letters left? Okay, if you write down caterpillar, and we cross out A's, we cross out the L's, we cross out the R's. Why do we do so? Because they have certain conditions given to us that both the R's are already included and at least one A has to be included and at least one L has to be included. So we don't count them when we think about the different arrangements. So what is left over here is 1, 2, 3, 4. 1, 2, 3, 4, 5. So 5 letters left. So from 5 we need to choose 2 to fill this remaining space. This is one possibility. The 2 R's are there. At least one A. Let's say we have both the A's. We need to have one L at least, and then there is one remaining space which can be filled by any other letter from the remaining 5. So the next possibility is 5C1. Okay, so let's play around with the L's now. Let's say there are 2 R's, 1 A and 2 L's. So again we are left with one space which can be filled up by any other letter. So this is 5C1. It's also possible that you have the 2 R's there. We include both the A's and both the L's. That means there's no other space left to fill. So 5 from the 5 letters we choose none. So this works out to be 10, 5, 5 and this is 1. So the total number of ways would be that would be 21. Alright, so that's about this question. Question 5. A group of 12 people consists of 3 boys, 4 girls and 5 adults. In how many different ways a team of 5 people can be chosen from a group if exactly one adult is included? So we have to choose a team or form a team of 5. 1, 2, 3, 4, 5. And exactly one adult is included. Okay, so we have one adult out of 5 adults and the remaining could be anybody, boys or girls. So now first thing we need to think about the adult. So in all we have 5 adults and only one adult is to be chosen. So how do we choose that? So we have from 5 adults we choose 1. 5 choose 1. Okay, so what are the remaining people left? 3 boys and 4 girls, so total 7. Yeah, so from 7 you choose the remaining 4. So from 7 you choose the remaining 4. So this works out to be 175. Alright. Part B. In how many ways can a team of 5 people be chosen from a group if the team includes at least 2 boys and at least 1 girl? So we have at least 2 boys and at least 1 girl. So I'm just going to write down over here. We have total of 3 boys and we have 4 girls and we have 5 adults. Again, we need to choose a team of 5 people, right? At least 2 boys and at least 1 girl is mandatory. The remaining could be anybody. Okay, so we have to choose 2 boys. So out of 3 we choose 2. 3 choose 2 for the boys. Then out of 4 girls we choose 1 girl, and out of the 5 adults we choose 2 adults because there are 2 spaces left. Likewise, we need to think what are the different possible combinations. Yeah, so let's play around with the girls first. So boys, 2 boys are there, at least 2 boys, and let's say we choose 2 girls and the remaining would be an adult. So this is 3 choose 2 times 4 choose 2 times 5 choose 1. Again, we could also have 2 boys and we could have 3 girls. In this case, it would be 3 choose 2, 4 choose 3 and 5 choose 0. We did not choose any adult. So that's the possibilities with the girls. So let's play around with the boys now. So let's say instead of 2 boys, I choose 3 boys and 1 girl. And the remaining is an adult. So from 3 choose 3. Then we choose 4 choose 1. And we have 5 choose 1. Also possible that you have chosen all the boys and you choose 2 girls. So 3 choose 3 times 4 choose 2, and no need to write, but if you want you could write 5 choose 0. Okay, so let's work this out. This works out to be 120. Then that is 12, 20. Oh, apologies. I think this works out to be 90. That is 12. That is 20. And the last one is 6. And the total would be then 248. Moving on to the last part, make sure to hit the subscribe button. The last part is pretty unique and quite different from the rest of the questions that we have discussed over here. The same group of 12 people stand in a line. How many different arrangements are there in which 3 boys stand together and an adult is at each end of the line? Remember, now we have 3 boys, so they stand together. If they're standing together, don't try and think about applying the method that I gave you before. All minus together, all possibilities minus together will not work because there are 3 boys. So when 3 boys are there, we cannot do all minus together because then we don't take into account 2 boys being together and 1 boy not being together. So that possibility makes problem. Yeah. So how would we approach this? Let's think. So we have an adult at each end. So we have adult at each end. And then the 3 boys are together. So let them be somewhere here. They could be anywhere. Okay. So we are now 12 people. So 12 minus 5, we are left with 7 people to arrange. Yeah. So 1, 2, 3, 4, 5, 6, 7. So 7 people to arrange. So 7 plus the boys together. Can we count this as 8 then? So total 8 items to arrange. So that can be done in 8 factorial ways. Then these 3 boys can shuffle around themselves. There are 3 different people, so they can sit anywhere they like, but they have to sit together. So that would be 3 factorial ways for the arranging the 3 boys. Then we have the adults. The first adult can be chosen in 5 adults. From the 5 adults, you choose the first one. Now the last adult sitting here, there are 4 adults left. So 4 choose 1 again. So instead of doing this, you may want to write this as 8 factorial times 3 factorial times, you could use 5 permutation 2. What's the meaning of that? It means that from 5 adults, we need to arrange 2 adults in these 2 places. Yeah, so that is 5 permutation 2. If you are going to use choose, then you have to write it a little bit longer. You got to do 5 choose 1, then 4 choose 1. The easier way would be 5 permutation 2. So this works out to be 4,838,400. All right, that's about the revision for permutation and combination. Remember to like, share and subscribe if you haven't done so yet, and see See you in the next tutorial. Thank you for watching.